Welcome to today's lesson. It is called, Is My Product in the Ballpark? A Powers of 10 Estimation Strategy. And today we are going to take the learning we have done previously on extending math facts and our understanding of powers of 10 to estimate the reasonableness of products. So let's get into it. All right. Our learning target is up here at the top of the screen. And it says, I can use a powers of 10 strategy to check the reasonableness of products. So the expression in the ballpark, that comes from our title, is used when an answer to a question, like a math problem, is close to, but not exactly correct. For example, let me get that out of there. For example, student says 3 plus 4 is 9. The teacher says, well, almost, you're in the ballpark. When solving problems, it is very important to think about whether an answer makes sense, right? Because if the answer doesn't make sense, you got to go back and maybe revise or fix, right? So today's power of 10 estimation strategy will help you figure out whether or not your answer to a multiplication problem, which is called the product, makes sense. Our strategy has 3 steps. Let's break them down. Step 1, we're going to round each factor to the nearest power of 10. Factors are the numbers we multiply together. Step 2, we're going to solve the extended math fact, multiplication fact. That comes out of those previous lessons. And step 3, boy, I keep getting in the way, don't I? Step 3, compare the size of the estimate that we make to the size of the product. If they're close, you're probably in the ballpark and you might have a right answer. If they're not close, you're not in the ballpark and you might have to go back and revise. Let's try a problem together. All right. Mr. Duranis thinks, look at that hat on Mr. Duranis. Isn't that a good looking hat? That's our ballpark. Okay. So he thinks to himself and solves a problem. 492 times 63 is 480,992. So he wants to check the reasonableness of this answer, right? Just like you might as well. So step 1, we are going to round each factor to the nearest power of 10. Now, because we're beginning, I have some number lines here to help us. Let's round 492 first, shall we? Let's see, 492, what multiple of a power 10 is that really close to? Well, 400's here on the number line. And 92 is really, it's way over here, isn't it? So we're really close to 500, aren't we? So this is like 492 right here. Yeah. All right. So we're going to call 492 500. All right. 492 now becomes 500. Now let's estimate 63. Well, let's use the number line here. That goes 0 to 100. 63 would be right about, let's see here. Here's 50. There's 65. So 63 is right about there. Is that about right? 63. So that's really close to, say 60, right? 63 is close to 60. So now we're going to have, let's see here. Let me get myself out of the way again. Let's see. 500 times 60. That's 63. Now we've rounded to become 60. So 492 times 63 has become 500 times 60. That's an extended math fact. So we'll go back to step 2, solve the extended math fact. Let's do it. All right. Well, step 1 of that process that we learned in previous classes, 5 times 6 is 30. And then we'll count up our zeros, 1, 2, 3. And we'll add those in, 1, 2, 3. Add our comma, and there is our estimated product, 30,000. So, final step 3, compare the size of the estimate to the size of the product. Well, if we go and do that, let's see here. The product we got was 480,992, and our estimate was 30,000. Are those close? No, those aren't close at all. So we know we have definitely done something wrong. The answer can't be right, and therefore, Mr. Duranis is not in the ballpark. with his thinking. So we got to go back and revise our answer and rework it. That is how this strategy works. Let's try another one. All right. Now, Mr. Geronis' twin, Mr. Geronis 2, he's thinking to himself this problem. 72 times 689 equals 490,608. Let's check to see if that answer is reasonable so we can know if we're in the right ballpark and whether or not we might have to go back and revise if we're not in the ballpark. So brought out some number lines here again to help us because we are just learning. And it's good to have a visual model to help us round. Let's start with 72. 72 on the number line here, 0 to 100. Let's see, there's 60, 70, 80, there's 75, right? So 72 is a little bit closer to 70. And so let's sit right there. Let's call that 72. So that's really close to 70. So let's go ahead and call 72 70. All right. And now we have to do 689. So let's go ahead and use our 0 to 1,000 number line. And let's see, here's 300, 400, 500, 600. 89 would be way close to 700 right over there. So that's like right about here is 689. That's really close to 700. So let's go ahead and call 689 700. So now our extended math fact in step 2 of this process is 70 times 700. So how do we solve an extended math fact? Well, we first multiply the basic fact, which is 7 times 7 in this case. So we're going to get 49. And then we count up our zeros, 1, 2, 3. And that is how many zeros we add to the product, 49,000. Final step of this process. We have to compare our estimate to the actual product. Are we in the right ballpark? Well, the product is 490,608. The estimate's only 49,000. Those aren't even close. That's 49,000. That's only 1/10 of 490,000. So we aren't in the right ballpark. Oh no, Mr. Geronis, you were wrong again. Not in the right ballpark. Oh no. So we have to go back and revise the answer, don't we? That's how this strategy works. All right. We round each of the factors to the nearest power of 10. Then we solve the extended multiplication fact. And then we compare the size of that estimate to the answer to make sure we're in the right ballpark. So we can go back and revise if we're not. So let's go on now to our final problem. And you're going to help me with this one, okay? All right. So here we go. In this problem, Mr. Geronis is thinking, let's see here. He's thinking 1,182 times 291 equals 324,096. Is that answer in the right ballpark? Is it close? Is it reasonable? Well, let's go ahead and do this step by step. Right now, what I want you to do is round 1,182 to the closest multiple of a power of 10. Actually, you know what? Let's not. Let's do that one together. I'll have you do the next one. All right. So 1,182. Well, that's really close. If I had to draw a number line, let's see if I could draw a number line here. Oh, I got to click on my pen. If I drew a number line here, let's see, that'd be like, I don't know, if this is 1,100 and this is 1,200, 1,100 here, that's 1,150. So that means 1,182 would be like right here, which is really close to 2,000. I'm sorry, 200, 1,200, right? Let me grab that last. There we go. 1,200. So let's go ahead and turn 1,182 into 1,200. And now let's pause this video and you go ahead and round 291 to the nearest power of 10. And I'll meet you on the other side. Welcome back. Did you round 291 to 300? Well, I hope so. That is the closest power of 10 or multiple of a power of 10. All right. So now we're on to step 2. We have our rounded off factors. Step 2, we need to solve this extended multiplication fact. So go ahead and do that right now. Okay. Welcome back. Let's see. Did you first solve 12 times 3? Well, if you did, you're on the right track. 12 times 3 is 36. And then we have to count up 1, 2, 3, 4 zeros. And that's what we'll add to our, oh, I put that in the wrong spot. 4 zeros. 1, 2, 3, 4. Then we can start counting from the ones place. 1, 2, 3. That's where our comma goes right there. 360,000. So our estimated product is 360,000. What Mr. Geronis got here was 324,096. Are those close? Are they in the ballpark? Yes, they are. They're not. It's not exact. And remember, this is just an estimation strategy. But 360,000 is in the same ballpark as 324,000. They're both in the hundred thousands place as numbers. And 24 and 60 aren't too far apart. So we can expect that Mr. Geronis is probably correct here. There's not a real strong need to go back and do this a second time because we're in the ballpark. This estimation strategy works. So let's go ahead and, yes, put a little check mark in here. Yes, Mr. Geronis, you did it. You finally did it. You were in the ballpark. Way to go with your thinking. So when solving problems, it is very important to think about whether an answer makes sense. Today's Power of 10 estimation strategy will help you figure out whether or not your answer to a multiplication problem called the product makes sense. And to review, where can I put this? Right here. Step 1 is to round each factor to the nearest power of 10. And then step 2, we're going to solve the extended multiplication fact. And in step 3, we're going to compare the size of the estimate to the size of the product to see if we are in the ballpark, to see if our answer is reasonable. All right, let's practice.